72 hours. That is the window we are working with before this developing storm begins affecting some of the largest and most densely populated regions in the country. 3 days may sound like plenty of time, but in weather terms, especially with a system of this scale, it is the final preparation phase before conditions begin to deteriorate. This is not a vague possibility showing up 10 days out on a long-range chart. This is a defined and organized system that is already taking shape. The ingredients are aligning, the humidity is increasing, cold air is positioned. The track is becoming clearer with each new model run. What remains uncertain is not whether it will happen, but exactly how intense the impacts will be in specific locations. Over the next 72 hours, the atmosphere will transition from calm to active in stages. The first signs will appear as increasing cloud cover and subtle pressure changes. Then precipitation begins to develop. As temperatures interact with incoming moisture, the type of precipitation becomes the most critical detail. That is where this storm becomes serious. A difference of just 1 or 2 degrees at the surface can determine whether your area receives several inches of snow or a damaging layer of ice. A slight shift in the storm's path, even by 50 miles, can move the heaviest snowfall band from one metro area to another. That is why timing and positioning matter so much right now. Several major cities sit within what we call the high-risk corridor. This is the zone where temperature layers in the atmosphere are close to the freezing mark. In these setups, precipitation may begin as snow, transition to sleet, then freezing rain, or even briefly mix with plain rain before changing back again. These transitions are not minor details. They directly affect road safety, power lines, tree damage, and airport operations. When heavy wet snow accumulates, it adds weight to infrastructure. When freezing rain coats surfaces, it creates invisible hazards and increases strain on power grids. When strong winds follow precipitation, they compound the stress on already weakened systems. The reason this 72-hour mark is important is because it is the final period where preparation makes a measurable difference. Travel plans can still be adjusted. Supplies can still be secured. Vehicles can still be prepared. Charging devices, checking heating systems, and reviewing contingency plans now prevents rushed decisions later. In this update, I will break down the timeline in detail. We will look at when precipitation begins in each region. We will examine where snow is most likely to remain all snow, and where mixing becomes a threat. We will identify the cities most vulnerable to icing, heavy accumulation, and wind impact. Most importantly, we will clarify the specific windows when conditions shift from manageable to dangerous. Storms of this type rarely impact only one state. They move through corridors, affecting millions as they progress. Understanding when your city enters the impact zone allows you to stay ahead of the disruption instead of reacting to it. 72 hours is enough time to prepare wisely. There is not enough time to ignore it. Let's begin with how this system is forming and where it moves next. A strengthening low-pressure system is currently developing across the central United States. Over the next 3 days, this storm will gradually organize, intensify, and begin moving northeast. As it strengthens, it will draw moisture from the south while interacting with colder air already in place to the north. That collision of warm, moist air and entrenched cold air is what creates complex winter storms like this one. This is a classic setup. A surface low forms along a boundary where temperatures contrast sharply. Warm air flows northward ahead of the system. Young cold air presses southward behind it. As the low deepens, it strengthens the pressure difference across regions, which increases wind speeds. Meanwhile, rising air within the system produces widespread precipitation. There are 3 primary threats associated with this storm. The first threat is heavy snow. In areas where temperatures remain below freezing from the ground up through the atmosphere, precipitation falls entirely as snow. When lift within the storm intensifies, snowfall rates can increase quickly. Under the right conditions, several inches can accumulate in a short period of time. This kind of snowfall reduces visibility, slows travel, and adds weight to structures, especially when the snow is dense and moisture-rich. The second threat is freezing rain. This occurs when snowflakes melt into rain as they fall through a layer of warmer air above the surface, then refreeze upon contact with cold ground temperatures. and the result is a glaze of ice that coats roads, sidewalks, vehicles, and power lines. Even small amounts of freezing rain can create extremely dangerous conditions. Ice accumulation increases the likelihood of downed tree limbs and power outages because of the additional weight it places on infrastructure. The third threat is damaging wind. As the low-pressure system strengthens and moves northeast, the pressure gradient tightens. That leads to stronger gusts both during and after the main precipitation event. Wind amplifies impacts by reducing visibility in snow, blowing precipitation sideways, and increasing stress on ice-coated trees and lines. After the storm passes, colder air rushing in behind it can produce additional wind-driven hazards. One of the most critical variables in this entire setup is the rain-snow line. This is the boundary that separates areas receiving mostly snow from areas experiencing a mix or freezing rain. That line is not fixed. It shifts depending on the exact track of the low-pressure center and the depth of cold air at the surface. A movement of just 50 miles north or south can completely change expected outcomes for a city. A location forecast to receive 8 inches of snow could instead experience a messy mix with much lower accumulation. Another area projected to remain mostly rain could suddenly fall into the colder sector and see accumulating snow. This is why meteorologists monitor track trends so closely during the final days before impact. Small changes in storm position alter temperature profiles at multiple atmospheric levels. Those changes determine precipitation type, accumulation totals, and infrastructure risk. As this system moves northeast over the next 3 days, it will strengthen in stages. Precipitation will expand outward from the center. Snowbands will organize in the colder air north and west of the track. Mixing zones will form near the temperature boundary. Wind speeds will increase as the pressure difference intensifies. Understanding the structure of this system is essential because it explains why impacts vary so much from city to city. No two locations experience the same storm in exactly the same way. Position relative to the low center, elevation, and temperature layers all shape the final outcome. This is a dynamic system with measurable components. Over the next updates, we will focus on how those components translate into timing and impact windows for specific regions. Between 72 and 48 hours before full impact, the early stages of this storm begin to unfold. During this period, the atmosphere transitions from preparation to activation. Moisture increases across the central United States as the strengthening low-pressure system pulls in air from the south. Clouds thicken, pressure begins to fall, and precipitation starts to develop in scattered areas. The first measurable precipitation is expected to appear across Missouri, Illinois, Indiana, and Kentucky. At this stage, intensity may be light to moderate, but this is the signal that the storm is organizing. Road surfaces begin to cool, especially overnight, which sets the stage for more significant impacts later. Even light precipitation during this window can create slick spots where temperatures hover near freezing. As the system gains structure and begins tracking northeast, colder air positioned across the upper Midwest and Great Lakes interacts with incoming moisture. That interaction allows snow to expand northward and eastward into Chicago, Detroit, and parts of northern Ohio. In these areas, temperatures are expected to remain cold enough through a deep layer of the atmosphere to support steady snowfall rather than mixing. Snowfall rates during this period may begin gradually, but they often increase as lift strengthens within the storm. The snow type in places like Chicago and Detroit is likely to be moderately dense, meaning it contains more moisture and adds noticeable weight as it accumulates. While totals may still be building during this time frame, travel conditions begin deteriorating once accumulation starts to cover roadways. At the same time, a more complex threat begins developing just south of the colder snow zone. Southern Michigan, central Indiana, and western Pennsylvania sit closer to the temperature boundary, separating snow from rain. In these areas, the atmosphere may contain a thin layer of warmer air above the surface, while ground temperatures remain at or below freezing. That structure creates the potential for freezing rain. Snowflakes falling from higher altitudes melt into liquid as they pass through warmer air, then refreeze when they reach the cold surface. This process results in a glaze forming on untreated roads, bridges, sidewalks, and elevated surfaces. Unlike snow, which can be plowed and cleared more easily, ice bonds directly to surfaces and becomes much harder to manage. During this 72 to 48-hour window, ice accumulation may begin lightly, but it is the trend that matters most. If model guidance continues to show sustained freezing rain in these transition zones, the risk to power lines and trees increases. Ice does not need to be thick to create problems. Even a small coating adds stress when combined with wind or additional precipitation. This period is also when travel plans become more sensitive to changing forecasts. Airports across the Midwest begin adjusting schedules based on expected precipitation type. Our highway departments prepare equipment. Utility companies monitor potential outage corridors where ice could become more significant. It is important to understand that impacts during this phase may still be uneven. Some neighborhoods may see primarily snow, while others only a short distance away experience sleet or freezing rain. Elevation, surface temperature, and proximity to the storm track all influence outcomes. The 72 to 48-hour window is when preparation transitions into awareness. Conditions may not yet be severe everywhere, but the pattern is clearly shifting. Snow coverage expands across the colder northern tier. Ice risk grows within the mixing corridor, and the storm's northeast movement brings larger population centers closer to their respective impact windows. This is the stage where monitoring updates becomes critical. Small adjustments in temperature profiles or storm track will determine how precipitation evolves as the system continues intensifying and moving eastward. Within 48 to 24 hours before impact, the storm begins to show its full structure. This is when organization becomes obvious on radar and satellite imagery. Precipitation becomes steadier, coverage expands, and intensity increases. Forecast uncertainty narrows, and impact zones become more defined. Across Chicago, Milwaukee, Grand Rapids, and the northern suburbs of Detroit, heavy snow bands begin forming as lift strengthens within the cold sector of the storm. These bands are areas where upward motion in the atmosphere is strongest, allowing snow to fall at higher rates. When these bands settle over one location, accumulation can increase quickly over a short period of time. Snowfall during this window is not light and intermittent. In the strongest bands, rates may exceed 1 inch per hour. Visibility drops significantly, especially during evening and overnight hours. Road crews begin struggling to keep up where snowfall intensifies and untreated surfaces become snow-covered quickly. The type of snow matters as well. When temperatures hover near the freezing mark, snow can be wet and compact, adding more weight per inch compared to lighter powdery snow. This increases stress on tree branches and infrastructure, particularly if wind speeds increase behind the system. While northern portions of the Detroit metro remain primarily in the snow zone, southern Detroit suburbs move closer to the transition boundary, where temperatures fluctuate slightly above freezing at certain atmospheric layers. That subtle change introduces a higher risk of mixed precipitation. A shift from pure snow to sleet or freezing rain drastically alters impacts. Snow can be plowed and treated more effectively. Ice adheres to surfaces and builds layers. Southern sections of the metro area may experience periods where precipitation changes type multiple times as the storm evolves. These transitions create unpredictable road conditions and complicate travel decisions. Farther east, Cleveland and Toledo enter a more concerning phase for icing potential. These cities sit near the temperature gradient where warm air aloft overrides cold surface air. As moisture continues feeding into the system, freezing rain becomes increasingly likely. Ice accumulation begins building on exposed surfaces, including power lines, bridges, and elevated roadways. State College and portions of western Pennsylvania are also positioned in a vulnerable corridor. Cold air trapped near the surface in valley regions enhances freezing rain risk. In these locations, ice may accumulate steadily over several hours rather than falling as brief bursts. The duration of freezing rain is often more important than intensity when evaluating damage potential. Or as precipitation intensifies across this broader region, snowfall continues north of the rain-snow line, while icing increases just south of it. The dividing line between these two impacts remains sensitive to small temperature differences. If the storm track shifts slightly north, snow areas expand. If it shifts slightly south, the ice corridor widens. Wind speeds also begin strengthening as pressure gradients tighten around the low-pressure center. Stronger gusts during heavy precipitation can reduce visibility further and increase the likelihood of tree damage where ice is present. In snow-dominant regions, wind may cause localized drifting, especially in open areas. Transportation systems feel increasing strain during this period. Airports monitor runway conditions. Highway departments deploy additional crews. Public transit systems adjust schedules in anticipation of heavier accumulation. More the 48 to 24-hour window is when the storm becomes fully active across major population centers. Snow bands solidify. Ice accumulation begins creating structural stress. Travel hazards escalate. Confidence in impact zones improves, even as small variations in track continue to influence final totals. From here forward, attention shifts toward the peak impact period, when conditions reach their highest intensity and disruption becomes widespread. The peak impact window unfolds during the 24 hours leading up to the storm's arrival and extends through the overnight period. This is when the system reaches maximum organization, precipitation intensity increases, and disruptions become widespread. Conditions shift from developing to fully active, and the most significant impacts occur within a relatively short span of time. Precipitation becomes steady and, in many areas, heavy. Travel conditions deteriorate rapidly as snowfall rates increase or freezing precipitation coats untreated surfaces. Visibility drops under stronger bands of precipitation, especially after sunset when temperatures cool further and road surfaces freeze more quickly. Philadelphia finds itself positioned near the temperature boundary separating snow from mixed precipitation. This location makes the forecast more complicated. Snow may fall initially, but periods of sleet are possible if slightly warmer air pushes into the mid-levels of the atmosphere. That transition can reduce overall snowfall totals but increase road hazards due to compacted sleet layers beneath fresh snow. Even a brief mixing period changes surface conditions significantly, especially during high traffic hours. New York City sits deeper within the colder sector of the storm if the projected track remains stable. In that scenario, heavy wet snow becomes the primary concern. Wet snow carries higher moisture content, meaning each inch weighs more than lighter powder-like snow. As accumulation increases, the added weight strains tree limbs and overhead lines. Urban infrastructure faces stress not just from accumulation, but from the volume of people impacted. Public transportation delays, airport disruptions, and slowed emergency response times become more likely as snowfall intensifies. Hartford and Providence remain solidly within the snow zone under the current track projection. In these cities, temperatures are expected to stay cold enough throughout the atmospheric column to maintain snowfall rather than mixing. Consistent snow during the overnight period leads to steady accumulation. Plowing operations continue throughout the night, but heavy rates can outpace clearing efforts temporarily. Boston occupies a more sensitive position near the northern edge of the heaviest precipitation shield. Small variations in the storm's path determine how much moisture reaches the city. A slight shift south reduces totals. A slight shift north brings heavier accumulation. Because of this positioning, Boston's forecast remains closely tied to the final trajectory of the low-pressure center. Even within the metro area, totals may vary depending on elevation and proximity to the coast. Wind becomes an increasingly important factor as the storm intensifies. Gusts between 40 and 50 miles per hour are possible in exposed areas, particularly closer to the coastline and within open terrain. Stronger gusts combined with heavy wet snow create additional hazards. Snow can blow sideways during intense bursts, reducing visibility for drivers and pedestrians. Ice-coated branches may snap under pressure when wind stress increases. Localized power outages become more likely wherever snow accumulation combines with gusty conditions. While widespread outages depend on the extent of ice and wind overlap, scattered interruptions are a realistic possibility. Crews often work continuously through peak conditions, but restoration times vary depending on the number of affected areas. Road conditions worsen as precipitation continues overnight. Temperatures remain cold enough in snow-dominant regions to allow accumulation on untreated surfaces. In mixing zones, compacted sleet and refrozen moisture create slick layers beneath fresh snowfall. Black ice forms in spots where melted precipitation refreezes as temperatures drop behind the storm's center. Air travel disruptions escalate during this period as de-icing operations slow departures and reduced visibility impacts arrivals. Highway travel slows significantly across major corridors. Emergency services monitor accident response closely, especially during late night and early morning hours when visibility and reaction time decrease. This peak window represents the highest intensity phase of the storm. Snowfall rates reach their maximum in core bands. Ice accumulation stabilizes or increases in transition zones. Wind amplifies existing hazards. Population centers across the Northeast experience measurable impacts simultaneously, making coordination and preparation essential. As the system begins shifting offshore, attention will turn toward post-storm conditions and the arrival of colder air behind it. But during this window, conditions remain active, impactful, and demanding full awareness from affected regions. Every major storm has areas where the impact is amplified due to geography, temperature structure, or population density. In this case, 3 regions stand out as carrying the greatest overall risk based on current projections. The concern is not limited to snowfall totals alone. It involves a combination of ice accumulation, infrastructure vulnerability, and the number of people affected. The first high-risk zone is southern Michigan, particularly the corridor between Detroit and Grand Rapids. This region sits in a delicate temperature zone where freezing rain is more likely than pure snow. Ice is often more destructive than heavy snowfall because it bonds directly to surfaces and builds in layers. Even a quarter-inch of ice creates serious hazards. Tree limbs begin bending under added weight. Power lines experience stress. When wind is added to the equation, the likelihood of scattered power outages increases substantially. Roadways in this region become especially dangerous during freezing rain events. Ice forms a nearly invisible coating, making braking and steering unpredictable. Bridges and overpasses freeze first, creating sudden changes in traction for drivers. Because southern Michigan includes both urban centers and heavily wooded suburban areas, the risk extends beyond transportation into residential neighborhoods where downed limbs can block roads and damage property. The second high-risk zone centers on central Pennsylvania, especially near State College and surrounding higher elevations. This area is vulnerable because cold air tends to become trapped near the surface while warmer air moves overhead. That setup favors prolonged freezing rain rather than a quick transition back to snow. When freezing rain persists for several hours, accumulation becomes more significant. Infrastructure in this region includes rural road networks, wooded terrain, and smaller power distribution lines that are more susceptible to ice damage. A sustained icing event here can lead to widespread outages across communities that are not as densely populated as major metropolitan areas, making restoration efforts more time-consuming. The terrain also complicates travel, as hills and winding roads become treacherous when coated with ice. The third high-risk zone is the New York City metropolitan area. The concern here is not solely about extreme snowfall totals, but about scale. Even moderate to heavy snow becomes highly disruptive when it affects millions of residents simultaneously. Transportation systems operate near capacity during normal conditions. Add accumulating snow, reduced visibility and slippery surfaces, and delays multiply quickly. Heavy wet snow in this region increases the strain on trees and power lines, especially in outer boroughs and suburban areas of northern New Jersey and Long Island. Airports in the region handle some of the highest traffic volumes in the country. Snow removal and aircraft de-icing operations slow departures and arrivals, leading to cascading delays nationwide. Population density also increases emergency response challenges. When road conditions deteriorate, even minor accidents can create significant traffic congestion. Public transit systems must adjust operations for safety, which affects commuting patterns across the entire metro area. Each of these 3 zones carries risk for different reasons. Southern Michigan faces the structural threat of ice accumulation. Central Pennsylvania confronts prolonged freezing rain potential in complex terrain. The New York City metro area must manage high population exposure combined with infrastructure strain. Understanding why these locations stand out helps clarify where preparation efforts matter most. While surrounding regions will experience impacts as well, these three areas combine meteorological factors with logistical challenges that elevate overall risk. Monitoring updates closely in these zones remains essential as the storm continues to evolve. When the storm system finally shifts offshore and precipitation begins to taper off, many people assume the worst has passed. The snow stops falling, the radar clears, the wind gradually weakens. It feels like relief. However, the period immediately following a winter storm can be just as dangerous as the height of the event itself. Behind the departing system, colder air often rushes in quickly. This temperature drop can be sharp and immediate. And surfaces that were previously wet from melting snow, sleet, or rain begin to freeze solid. Even areas that appeared only damp during the storm can transform into sheets of ice once the cold air settles in. This is how black ice forms. Black ice is especially dangerous because it is nearly invisible. It does not look like thick ice or packed snow. Instead, it creates a thin, transparent layer that blends into the pavement. And drivers may not realize they are on ice until they try to brake or turn and discover that their tires no longer have traction. The morning commute after a storm is often when problems increase. Roads may look clearer than they did during peak snowfall. Plows may have passed through major highways, snowbanks may be pushed aside, but what remains is moisture trapped on asphalt, bridge decks, and shaded side streets. Once temperatures fall below freezing, that moisture hardens. Bridges and overpasses freeze first because cold air circulates above and below the structure. Elevated surfaces lose heat faster than roads built directly on the ground. Drivers traveling at normal speeds may encounter unexpected slick patches on these sections, leading to sudden loss of control. Parking lots and residential streets present another hazard. Snow that was partially cleared can melt slightly during daylight hours, then refreeze overnight. Early morning traffic on these untreated surfaces often results in sliding vehicles and minor collisions. Another factor to consider is human behavior. During the storm, drivers tend to move cautiously. They expect poor conditions. Visibility is reduced and snow accumulation is obvious. Once the storm ends, confidence returns too quickly. People assume roads have improved simply because precipitation has stopped. Speed increases. Following distances shorten, and that change in behavior increases the likelihood of accidents. Cold temperatures following a storm also affect infrastructure. Ice that formed on trees and power lines may remain frozen in place for several days if temperatures stay low. Even light wind can cause weakened branches to break after the storm. Falling limbs sometimes occur hours or even days after the final snowflake falls. Pedestrians face additional risks as sidewalks and driveways refreeze. Compacted snow becomes hard and slick. Ice hidden beneath a thin dusting of fresh snow can cause sudden slips and falls. Injuries frequently rise during this period as people begin clearing driveways and walking outdoors more frequently. Vehicles may also struggle in post-storm cold. Batteries weakened by freezing temperatures can fail overnight. Tire pressure drops as air contracts in colder conditions. Diesel engines, in particular, may experience starting issues when temperatures fall sharply. The psychological shift after a storm often leads to underestimation of ongoing risk. Snow removal creates a sense of completion, but the freeze that follows creates a new layer of hazard. Roads that appear mostly clear can remain unpredictable, especially during early morning and late night hours. Staying cautious during the days following a storm is just as important as preparing before it arrives. Slowing down, increasing following distance, and assuming that any wet-looking surface could be frozen helps reduce the chance of accidents. Even small adjustments in driving behavior can prevent serious incidents. A winter storm does not truly end when the clouds clear. The cold that follows can extend its impact well beyond the final snowfall. Respecting that extended risk period ensures safer travel, fewer injuries, and better overall recovery from the event. Forecast confidence currently sits in the moderate range. That means the overall setup is clear and the storm will occur, but certain details still depend on how a few critical elements evolve over the next model cycles. In winter storms like this, small differences in storm track and temperature structure can significantly change local impacts. The first key variable is the exact path of the low-pressure center. The low acts as the organizing force of the system. Its position determines where the coldest air remains locked in and where warmer air pushes northward. A shift of even 50 miles can move the rain-snow line across major population centers. If the low tracks slightly farther north than currently projected, warmer air aloft reaches deeper into the northeast. In that scenario, some coastal areas could see lower snowfall totals as mixing becomes more likely. Cities positioned close to the temperature boundary would experience more sleet or rain instead of sustained snow. However, areas farther inland and north of the track would remain firmly in the cold sector, potentially seeing higher snowfall totals as the heavier precipitation shield shifts in their direction. On the other hand, if the low trends south, colder air holds its ground longer across parts of Pennsylvania, northern New Jersey, and interior portions of the mid-Atlantic. That shift increases the potential for freezing rain, where surface temperatures remain below freezing but warmer air sits above. Ice accumulation becomes more likely in those transition zones, raising concerns about power outages and hazardous travel. Surface temperature profiles are just as important as track. Even when the low follows the projected path, subtle variations in ground temperature determine precipitation type. A difference of 1 or 2 degrees can change snow to sleet or sleet to freezing rain. Overnight cooling, elevation differences, and urban heat effects all play a role in these outcomes. Meteorologists evaluate multiple forecast models to assess these possibilities. Some models handle temperature profiles more accurately in shallow cold air situations. Others may better capture storm intensity or precipitation distribution. Comparing these solutions helps narrow the range of realistic outcomes. Moderate confidence does not mean uncertainty about the storm itself. It means that while the event is expected, the precise location of the heaviest snowband and the width of the ice corridor are still being refined. As the system moves closer and more real-time data feeds into the models, projections become sharper. Another factor influencing confidence is how quickly the storm strengthens. A deeper low-pressure system often produces stronger lift and heavier precipitation. A rapid intensification can also tighten pressure gradients, increasing wind speeds. Forecast models attempt to capture these changes, but small timing differences in strengthening can alter impact windows. The rain-snow line remains the most sensitive boundary in this setup. Cities near that dividing line should pay close attention to updates, as even minor adjustments can influence totals significantly. Communities clearly north of the line are more likely to remain in the snow zone. Areas clearly south are more likely to see primarily rain. It is the middle corridor where the highest variability exists. As new model runs arrive over the next 12 to 24 hours, forecasters will watch for trends rather than isolated shifts. Consistent movement in one direction increases confidence in that outcome. Erratic swings between runs signal that the atmosphere is still balancing competing influences. In summary, the storm's presence is well supported by the data. The general impact zones are established. The remaining uncertainty lies in precise placement and precipitation type boundaries. Continued monitoring will clarify whether snowfall totals increase inland, ice risk expands southward, or the rain-snow line stabilizes closer to its current position. Staying informed during this period ensures that adjustments can be made quickly if confidence shifts in one direction or another. The time before a winter storm arrives is the most valuable opportunity to reduce risk. Once precipitation begins and temperatures drop, options become limited. Acting early provides flexibility and prevents rushed decisions under pressure. The goal is not panic, but practical preparation. Start by reviewing any travel plans scheduled during the projected impact period. If driving can be postponed or rescheduled, consider doing so. On-road conditions during heavy snow or freezing rain deteriorate quickly. Even experienced drivers struggle when visibility drops and traction disappears. If air travel is planned, monitor airline notifications closely and consider earlier departures if possible. Waiting until the last minute often means competing with thousands of others trying to adjust their plans at once. Vehicles should be ready for winter conditions. Check tire tread depth and ensure proper inflation, since cold air reduces tire pressure. Verify that windshield washer fluid is filled with freeze-resistant solution. Test windshield wipers to confirm they clear effectively. Keep the fuel tank at least half full to prevent fuel line freezing and to ensure heat can run if delays occur. Inside the vehicle, basic emergency supplies can make a significant difference. Blankets provide warmth if traffic stalls for extended periods. A flashlight with fresh batteries ensures visibility if power fails at night. Bottled water and non-perishable snacks help sustain passengers during unexpected delays. A small shovel, gloves, and traction material such as sand or cat litter may assist if a vehicle becomes stuck. At home, focus on readiness for short-term power interruptions. Charge mobile phones, tablets, battery packs, and essential electronics in advance. Locate flashlights rather than relying solely on candles, which increase fire risk. Confirm that smoke detectors and carbon monoxide alarms are functioning properly. If medical equipment requires electricity, identify backup options ahead of time. Contact local utility providers to understand procedures for outage restoration priorities. Refrigerated medications should be grouped together in case transfer to a cooler becomes necessary. Heating systems deserve attention before temperatures drop further. Replace furnace filters if needed. And ensure vents are unobstructed. If using alternative heat sources, such as fireplaces or generators, verify that they are in safe working condition. Generators must always operate outdoors, far from windows and doors, to prevent carbon monoxide exposure. Water preparation is also important. In areas expecting freezing temperatures, allow a slow drip from faucets connected to vulnerable pipes to reduce freezing risk. Know the location of the main water shutoff valve in case a pipe bursts. Community awareness strengthens overall safety. Check in with neighbors who may need assistance, especially elderly individuals or those living alone. Share contact information in case communication becomes difficult during outages. Small acts of coordination reduce isolation and speed recovery. Households should also prepare for communication disruptions. Keep written emergency contacts available in case devices lose power. Identify a meeting plan for family members if travel delays occur. Financial preparation can help manage extended disruptions. Have small amounts of cash on hand in case electronic payment systems become temporarily unavailable. Store essential documents in waterproof containers. Mental preparation matters as well. Winter storms often cause frustration due to cancelled events and changed plans. Approaching the situation with patience reduces stress and supports better decision-making. Preparation does not require extreme measures. It involves thoughtful, measured actions taken before conditions deteriorate. Small steps completed now can prevent larger problems later. When the storm begins, those who prepared early will navigate it with greater confidence and fewer complications. Taking action ahead of time transforms uncertainty into readiness. There are 72 hours left. That window is meaningful. It represents the difference between reacting to a storm and preparing for it. Weather systems move on their own schedule, but how we respond is entirely within our control. 3 days provide enough time to make thoughtful adjustments, review plans, and secure what matters most. Over the next 24 hours, forecast data will sharpen. Each new model run adds clarity to the storm's exact path, intensity, and temperature structure. Small refinements in track help determine where the heaviest snow bands settle and where the mixing zone shifts. These updates are not dramatic swings, but gradual adjustments that narrow the range of possible outcomes. As more observational data feeds into forecasting models, confidence increases. Weather balloons, satellite imagery, radar trends, and surface observations all contribute to refining projections. That steady stream of information allows forecasters to fine-tune impact windows and precipitation types for individual cities. Storms like this are dynamic. They evolve as they move. What looks certain today may shift slightly tomorrow, which is why continued monitoring is important. Staying informed does not mean constant alarm. It means checking reliable updates at reasonable intervals and understanding how new information affects your specific location. Preparedness does not require fear, it requires awareness. When people understand what to expect, they make better decisions. Travel plans can be adjusted calmly. Supplies can be organized efficiently. Communication can remain clear. That steady approach reduces stress and increases safety. As this system approaches, focus on the fundamentals. Know when precipitation begins in your area. Understand whether snow, sleet, or freezing rain is most likely. Be aware of temperature drops behind the storm that could lead to refreezing. Keep track of any official advisories issued by local authorities. Weather events remind us that conditions can change quickly. They also remind us that planning ahead makes a measurable difference. Communities that prepare tend to recover faster. Individuals who anticipate disruptions experience fewer complications. Updates will continue as new data becomes available. Forecast details will become sharper as the storm draws closer. Impact zones may be adjusted slightly north or south depending on temperature trends and track positioning. Those refinements are part of responsible forecasting. And 72 hours is not a long time in daily life, but in storm preparation, it is a valuable opportunity. Use it wisely, review what needs attention, make small adjustments where necessary. Confirm that your plans align with the latest information. Winter systems demand respect, not panic. Staying informed provides clarity. Staying prepared provides confidence. We will continue monitoring developments closely and provide updated information as the situation evolves. Stay informed and stay prepared.